Good morning, class, and welcome to today's lesson. And today we are in our chapter 2 of the unit climatology, which says the constituents of the atmosphere. The last time we spoke about the scope and development of climatology, whereby we realized the history and came to understand the modern forms climatology has taken, as well as the significance of climatology. Now today we are looking at the constituents of the atmosphere. Atmosphere is comprised of various gases and it has various components, one of them being the nitrogen. Nitrogen is removed from the atmosphere and deposited at the Earth's surface mainly by specialized nitrogen-fixing bacteria and lightning through precipitation. The addition of this nitrogen to the Earth's surface, soils, and various water bodies, it supplies much needed nutrition for plant growth. Nitrogen returns to the atmosphere primarily through biomass combustion and denitrification. Oxygen is another component of the atmosphere. Oxygen is exchanged between the atmosphere and life through the process of photosynthesis and respiration. Photosynthesis produces oxygen when carbon dioxide and water are chemically converted into glucose with the help of sunlight. Respiration is the combination with glucose to chemically release energy for metabolism. The products of this reaction are water and carbon dioxide. Let's look at water vapor. Water vapor varies in concentration in the atmosphere, both spatially and temporarily. The highest concentrations of water vapor are found near the equator, over the oceans and tropical rainforests. Cold polar areas are subtropical continents. Deserts are locations where the volume of water vapor can approach 0%. Water vapor has several very important functional roles in our planet. They being, it distributes heat energy on the Earth through latent heat energy exchange. The condensation of water vapor creates precipitation that falls to the Earth's surface, providing needed fresh water for plants as well as animals. Water vapor also helps warm the Earth's atmosphere through the greenhouse effect. And now water vapor is a very essential component of the atmosphere. Carbon dioxide. The carbon dioxide gas has increased by over 35% in the last 300 years. This increase is primarily due to human-induced burning of fossil fuels, deforestation, as well as other forms of land use change. Carbon dioxide is an important greenhouse gas. The human caused increase in its concentration in the atmosphere has strengthened the greenhouse effect and has definitely contributed to global warming over the last 100 years. Carbon dioxide is also naturally exchanged between the atmosphere and life through the process of photosynthesis and respiration. Methane is a very strong greenhouse gas, and since 1950, methane concentration in the atmosphere has increased by more than 150%. The primary sources for the additional methane added to the atmosphere are the following: domestic grazing animals, they add methane; termites add methane; landfills add methane; coal mining, as well as oil and gas extraction. Now let us look at how each and every one of these adds methane to the atmosphere. Rice cultivation. Anaerobic conditions associated with dry, paddy flooding results in the formation of methane gas. However, an accurate estimate of how much methane is being produced from rice paddies has been difficult to ascertain. More than 60% of all rice paddies are found in India and China. Nevertheless, where scientific data concerning emission rates are available, Nevertheless, scientists believe that the contribution of rice paddies is large because this form of crop production has more than doubled since 1950. Grazing animals release methane to the environment as a result of herbaceous digestion. Some researchers now believe in the addition of methane from this source has more than quadrupled over the last century. It has really increased, as you can see. And termites. Termites are said to release methane through similar processes also. Land use change in the topics. Due to the deforestation, ranching and farming may be causing termite number to expand. If this assumption is correct, the contribution from these insects may be important. Methane is also released from landfills, coal mines, and gas and oil drilling. Now let's look at the ozone layer as another constituent of the atmosphere. The ozone's role in the enhancement of the greenhouse effect has been difficult to determine. Accurate measurements of past, long term, which is more than 25 years in the past, levels of this gas in the atmosphere are currently unavailable. Moreover, concentrations of ozone gas are found in two different regions of the Earth's atmosphere. The majority of the ozone, about 97% of it, is found in the atmosphere, is concentrated in the stratosphere at an altitude of about 15 to 55 kilometers above the Earth's surface. The stratospheric ozone provides an important services to life on the Earth as it absorbs harmful ultraviolet radiation. In recent years, the levels of stratospheric ozone have been decreased due to the buildup of human-created chlorofluorocarbons in the atmosphere. Since the late 1970s, scientists have noticed that the development of severe holes in the ozone layer over the Antarctica satellite measurements have indicated that the zone from 65 degrees north to 65 degrees south latitude has had a 3% decrease in stratospheric ozone since 1978. Let us look at aerosols as a constituent of the atmosphere. In addition to gases, the atmosphere has a wide variety of suspended particles, known collectively as aerosols. The particles may be liquid or solid, and are small enough that they may require a very long time to settle out of the atmosphere by gravity. They include suspended soil or desert sand particles, smoke particles from wildfires, salt particles from evaporated ocean water, plant pollen, volcanic dust, and particles also formed from the pollution created by coal burning power plants. Aerosols significantly affect atmospheric through heat balance, cloud growth, and optical properties. And now, class, that marks the end of our lesson today. Let's meet again next time.